Welcome, everyone. My name is Ricardo Camacho. I'm the Director of Safety and Security Compliance at Parasoft. And thank you for joining us today for this demonstration to see how to simplify automated builds and testing for safety critical applications. The presenters today will be Parasoft's Miroslav Zielinski, Director of Product Management, and IAR Systems' Philippe Torrezan, Field Application Engineer. This is a collaboration between IAR and Parasoft in demonstrating how to develop your software using IAR solutions and in turn, how to test your software using Parasoft, all within a DevOps workflow. Now, before we get started, let's go through some housekeeping. Everybody's microphone has been muted. However, if you have questions, please enter them into the questions dialog box as shown in the image to the right. Now, there is time for Q&A that has been allocated at the end of the session, and you can also use the chat to send any questions to our staff. And don't forget, this presentation is being recorded and will be made available to you shortly after the webinar. The agenda will start with Philippe taking us through a live CI/CD workflow demonstration, followed by Merrick, where he will continue the demonstration, but with the static analysis testing being integrated into the workflow. Okay, I'm going to pass it on to Philippe for the demonstration. Welcome, Philippe, and great to have you here.
It's great to be here. I am Philippe Torrezan, Field Application Engineer for IAR Systems in Sweden. Before we head straight to the demonstration, let's recap what we are about to see. We will start here. Now I will basically wear the DevOps hat by building our Docker image containing everything my developers are going to need to build in our embedded application software. Ubuntu as the OS, the IAR build tools for building, the Parasoft C, C++ test to ensure compliance. And in this demonstration, we will use the CMake to generate build scripts as make files, just to show how flexible those tools can be when working in unison. As the image will contain everything, it will serve to the purpose to build and test locally, as well as within the orchestrated pipeline here on the CI/CD environment. Then Miroslav will take over as the developer, who will take the Docker image created and run it within a Docker container to develop his application, a new feature branch, and so on. After that, the developer will push some features branch into the version control system, which will trigger an automated building and testing pipeline. After that, the orchestrator will generate output with resources that will lead to online audits and offline reports. And those reports also can go back, those results can go back to the developer for remediation later on. And with that, we go to the Docker file now, please.
Okay, so let us switch to the demo VM. And here is our Docker file.
Thanks, Miroslav. Well, here is basically a Docker file based on a template that we have available on our GitHub page. github.com/IAR Systems. Then there is a repository for BXARM with Docker, where you can take that template and use it to build your own Docker image according to your needs. But basically, here is how it goes. It uses a pre-baked image from Ubuntu 2004, which is also an LTS version for Ubuntu. And then it takes this argument to keep the same user ID between the host side and the image side, so there are no permission issues. Here, of course, you might want to have some environment settings for your time zone, so you get proper timestamps when you're testing and building things. Environment variables to make it simple to propagate across different parts of the image later on. Update the basic tools that are required. Here you can add more as you need. Perhaps you want to build it with Ninja at some point. And here is how you create the user with the same user ID as in the host side. you can, of course, name it as you want. It's the reason we provide the Docker file, so you can customize to your own needs. Those two lines basically change the working directory to a Parasoft folder where you can copy simply all the binaries to its rightful place. And then you add it to the environment path of the image itself. Down below, it shows you how to simply install the Debian package for the build tools, IAR build tools. It's just a two-liner like this, and then you set a volume with the same permissions you would have for every user and group as the CI user here. Lastly, but not least, you need to set up your license with those two lines like this. There are other ways, and our tutorial at GitHub can show you how. And if you have questions about it, of course, you can reach out to us later on. Lastly, this image will also install a GitHub runner, which will enable building and testing from a local machine using the GitHub as an orchestrator for the CI environment. One important thing here that I also would like to mention is setting this LC all as C variable. This is a requirement we have seen in the field that customers trying to use CMake, if they don't set this variable, CMake won't work properly. And that's basically a way to set up a Docker machine that works for both development side and build sites as well. So now I will give back control to Miroslav so he can show us what the developer would do. Thank you.
Thank you, Felipe. So let's continue our journey. We're going to show you an example workflow with IAR compiler, CMake, Parasoft C++ test static analysis for MISRA compliance, and GitHub for CI/CD automation. If you are a Windows user, you will probably we will probably take you a little from the beaten path, but we hope you will find this inspiring. So at this moment, I'm wearing a developer's hat. As you can see, I'm using Visual Studio Code as my IDE, and I've just pulled the code from the repository to my laptop, and I want to start working on the new functionality. And the great thing about my setup is that thanks to Felipe and my DevOps team, I'm basically ready to go just after checking out the code. Code is pulled to my laptop, and my development environment with all the tools is in the container. And the configuration of my development environment is stored together with my source files. I'm using VS Code extension to automate working in containerized environments. Here you can see the configuration of my container. That's the name of the container image that contains our tool chains. So let me open now my project in the container. So what happens now is that Visual Studio Code starts the container and mounts my project stored locally as a volume to the container. So now I will be able to build and test the code using the tools in containers in completely transparent way for me. And as we mentioned a couple of times with containers, the great benefit of this kind of setups is that I could potentially have a number of such container configurations and easily switch between them using tools for different architectures or different versions of tool chains in a matter of minutes. All right, so as you can see, my project is configured for build with CMake. I have CMake list here. CMake was already executed, so I have all the build scripts. I can run the build, and here IAR compiler bxarm is called in the container. I have some warnings, but in general, my project was successfully built. It took a fraction of a second, and since my project builds, I'm ready to start working on new functionality. I will start with creating a feature branch. Let's call it feature ABC. And I will pretend doing something useful, and I will add some simple code here. Nothing sophisticated. Something like this. I can try if it builds. It builds successfully. So I've just implemented something, but my project is a safety critical application, and among many other things, many other regulations I need to fulfill, I have to be MISRA C 2012 compliant. So I need to make sure that the code I will merge with the master does not violate any of MISRA guidelines. So let me quickly use C++ test to scan my code. And for productivity, my testing is done in two phases. My local MISRA scans are focused on my code modification. C++ test uses a baseline report to understand which violations pre-existed in my parent branch, and it will show me only the new problems that are relevant to the new code I added. And also, to further speed up the analysis, I'm using limited number of static analysis checkers. My intention is basically to quickly scan the code and continue. And here you can see I have a configuration of my static analyzer saved together with my code in the form of a plain text file. And in the meantime, analysis was executed. As you can see, we have a problem located. This is a violation of one of the MISRA guidelines. Again, we are using very simple example here, so I even won't discuss the details. I will just fix the code. Here the prototype was required, and I will rescan it with C++ test to make sure that my code is now clean. Okay, it will take a second. And we have the information that no more problems are found. So I developed my new functionality. My local scan is clean. So I'm ready to commit my code to be built and test in the CI/CD with the complete and thorough set of MISRA checkers to make sure I did not miss something in my local scan. And for the CI/CD automation, as I mentioned at the beginning, I'm using GitHub. So this is what we'll be using. So let me commit my code. Okay. And now let me push my changes. I want to publish the branch. And my commit triggers CI/CD pipeline. Let me switch to GitHub now. And we see here that the pipeline was started and a sequence of actions is now executed, including building and testing. And there are two important things here. The definition of my pipeline is defined in the YAML file and stored together with my code. So this gives me a transparency. I can easily modify and change the configuration of my pipeline. Here you can see we are building using CMake, and here you can see we are running static analysis with C++ test. Second thing is that my pipeline is executed using the GitHub local runner started from the container. So I'm using exactly the same toolchain as for my local development. And this is a huge advantage. If I need to scale my CI/CD to handle many feature branches created by my team, I can do it in minutes and add more runners based on the same container image. And in the meantime, my pipeline has finished. And as you can see, we have some additional violations. Let me go here. This is to some degree expected, since in CI/CD I've included more complete configuration. So I have some additional findings, and here we have 2 occurrences of avoid division by 0 problem. So we can drill down here to see more details. And I can do, and I have, from this point, I have several options now. Depending on my team policy, if it's very strict, I cannot open pull requests with violations. I will have to fix them. So I can do it by checking details of the problems in GitHub. As you can see, C++ test integrates with GitHub, so the analysis results are available. So I will have enough information here to take a corrective action. I have a documentation of the rule available that was violated, and I have some additional information in case of this finding where we have a division by 0 problem. We have information about the path going from function to function to help us in understanding what is the problem and fix the code. So I can do it just by looking at the information in GitHub, or I can download the static analysis results to my IDE and review and fix the problems in the IDE. Optionally, if my team policy allows me to open the pull request with existing problems, existing violations, I can do so and discuss findings with my team as a part of the pull request comment thread. But we won't explore this any further, since our webinar today is mainly focused on the automation. So this is where we stop our discussion. If you are interested to learn more about the workflows, please contact us. But there is one more aspect which I would like to touch before we come to the conclusion. When we need to achieve compliance with the standards, we need reporting to document that all objectives have been met. And in our demonstration setup, we are using Parasoft DTP web-based reporting and analytics platform with MISRA compliance reporting. So here you can see a dashboard that contains MISRA, that contains information about our compliance process. It helps us to manage and plan actions to make sure we achieve compliance on time. And the great thing about this reporting system is that it automatically generates the reports that are required to successfully certify the code to pass the audit. And these reports are conform with MISRA 2020 Achieving Compliance reporting standard. So we have the main compliance report, we have guidelines recategorization plan, guidelines enforcement plan, all the reports basically that are expected from the mature compliance process. And with this being said, I think it concludes our demonstration. Using this simplified example, we presented how Docker containers and CI/CD can be used to simplify complex build and test development workflows, and reduce the burden related to achieving compliance.
And this, I believe, concludes our presentation. Handing back to you, Ricardo.